My name's Scott Snedden. I'm joined by Jeff Tansura today. We're on the data center team here at Juniper, and we focus on the Apstra intent-based system. So Jeff, my customer loves the idea of an EVPN VXLAN fabric, but when we started talking about how to actually design that network, they weren't sure to how to go about doing that. Let's say they want to build a leaf spine, 5-stage, 2-pod data center. It's easy to draw that on a whiteboard, but in reality, there's a lot of planning that needs to go into that. That detail can take days, maybe even take weeks. Can the Apstra intent-based system make that any easier?
Absolutely, Scott. Based on customer business intent, I've pre-built a couple of templates which I'm going to show you now. With regards to racks, I've pre-designed 2 racks. One of them is double rack with 4 servers for 1 pod with no external connectivity. And another one, very similar rack, but now with external router. So this is how our data center is going to look like. Now we are going to see how complete template looks like. It's rack-based, based on racks we have pre-designed. As we said, we would like to have 2 pods. For simplicity, 1 rack per pod. One of the racks is going to be connected to external router, while another not. So this is the template we are going to be using. This template could be exported and used across all of your data centers across the world. It's single template that's the foundation of your data center. So now we are going to build a blueprint, which is logical representation of your data center. I'm going to call it Scott because I like Scott a lot. I'm going to assign the template that you just seen. That's pretty much all I need to do. All the details are already predefined in templates and lower layer templates we've created for racks. So it will take a few seconds to create a new blueprint. Now we are going to see fully staged data center. It has no EVPN configuration. It has no services configured to it. It has only working underlay as per business intent. And to prove my point, I'm actually going into CLI of one of the leaves to show you what's going on. We are going to see that there are no VLANs configured. So as you could see, only default VLAN is configured. We are going to take a look at routing instance configuration. As you could see, the only routing instance that is present is one for management with default route towards management. We will also take a look at routing table to see that there is no routing tables associated with EVPN. So as you could see, this device, or actually whole fabric, is completely unconfigured, just working underlay configured in accordance to business logic. This is how whole fabric looks like. 5-stage, 2 pods. One of the pods is connected to external router, while another one is not. Back to you, Scott.
That's pretty slick, Jeff. So now we've got a design. That's probably going to be a lot of typing. You showed us that CLI, and we see that there's nothing there yet. Now, it's going to take a long time to type all that into the CLI. And frankly, my customer doesn't have a ton of expertise with BGP and configuring all the EVPN VXLAN stuff anyway. These are powerful protocols, but a lot of times customers, this looks really different than configuring VLANs and spanning tree and some of the stuff that we used to do. And then again, we also talk a lot about how customers need to develop an automation practice, but my customer, they need to get up and running today. They don't have time to overcome the learning curve of building an automation practice. Can you help with that? Can you help not only shorten the time to automate it, but also help with some of the complexity of that BGP configuration and EVPN VXLAN configuration?
Absolutely, would be happy to. And I love BGP. As long as I remember myself, I've been doing BGP, which goes back to 90s. Let's go into stage mode, and we are going to design our tenants now. So we are going to configure layer 2 tenancy. We're also going to configure layer 3 tenancy. We'll start with layer 3. We are configuring VRF or routing instance, and we'll call it again, guess what, Scott. What's important here, all details of this particular routing instance are going to be auto-derived. I'll also show you that if I'm missing some of the configuration, system will notify me. Look, you've configured something, but there's some data I'm missing and I cannot proceed. So the only thing I really needed here is to give it a unique name. As you can see, we've got routing instance called Scott configured. I've got number of resource pools for VNIs, route targets, VLANs. So I've picked first available VLAN, which is VLAN 2. And since my resource pool starts with VNIs of 10,000, it will get VNI 10,000. Route target is auto-derived from it, and it's 10,000 colon 1. However, you also see that the system is unhappy. Why is that? Because I didn't provide loopback IP. And guess, I'm not going to configure IP addresses here. I'm going to use one of the ranges I predefined before that is going to be applied to the routing instance. So as you could see, everything turned green and everything is happy. What's important? Nothing has been committed yet. We've only created intended configuration. So I'm not going to commit it yet. I'm going to add layer 2 stretching for the same VLAN. We are going into virtual again, and now we configure virtual network. We'll call it Scott again. I'm not going to be very unique here. I'm going to choose security zone to attach it to, and I'm going to enable IPv4 connectivity here. I can configure IP addresses myself or provide pool one. So for this case, I can actually configure it myself. Let's use RFC 8090 space and configure Anycast gateway. Anycast gateway is a very important property because it allows for VMs to seamlessly migrate. Let's create. I'm going to attach it to both pods. So as you could see, you can easily choose where your services are. I can say they're only going to be to deploy in pod 1 or in both pods. So for simplicity, let's use both pods. So as you could see also, there are all 4 leaves that are present in our blueprint. So all the resources have been assigned. As you could see, we are all green. So what we are going to do now is commit. As you could see again, everything is in committed state. So we've configured it, but it's only logical configuration on the system itself. Nothing has been configured on the switches. And we are going to commit. What's happening now, we are taking data models, run them through templating, and configure our configuration that is pushed to the devices right now. So if we are looking at active configuration now, it has all the configuration needed, and now we are going to see what's going on. So as we could see, everything is green and all configuration has been committed. And if we look at dashboard, we can see that there are no faults. Everything is working as expected. 0 anomalies anywhere. So to prove my points, now we are going to see the configuration, because proof is in the pudding. We got EVPN and INET 0 tables in routing instance Scott. Most importantly, routing table for EVPN is now present. Let's take a look at configuration. If we are looking at routing instance, we see Scott routing instance that has been configured. As we said, it has VNI of 10,000. and route target of 10,000 column 1. So everything is auto-derived for the system. Same goes to VXLAN for layer 2. Now we've got VN3 configured with VNI ID of 10,001. Remember, we've taken common pool, and now we are just monotonically increasing it. So we've used 10,000 for layer 3 and 10,001 for layer 2. If we are looking at routing table, we can see route being populated. So what you see now are route type 5 that are responsible for IP prefix routing. We don't see route type 2s because there's no traffic coming from the server. So what we have configured, to summarize, we've got fully working layer 2 and layer 3 segmentation for a customer. Scott.
Oh, are you done already?
Unfortunately.
I get distracted here in my home studio, and I thought I'd have a little more time. I mean, usually it takes, I don't know, at least an hour or two to roll out a network like that. That's pretty cool. So that's really great that we can push stuff out quickly. We can get things implemented and bring that data center up and have it running in minutes, as we just showed. Now let's take this scenario. Okay, so the application team just called and told the network engineering team that, surprise, surprise, that new app that they've been developing, well, it needs to be deployed tonight. I guess the marketing team is going to do a big social media campaign. They're expecting a ton of traffic. So that new app needs to be pushed out right away. So we don't have a week to configure the network. We've got to bring on this new tenant. We've got to provision all of the networking, VRFs, layer 2 segments, VTEPs, whatever else might need to happen to support that application. And, we know that configuring that manually will take all day, take a week. It usually takes a long time. And then to throw a wrench in the whole thing, the app team wants to put that application in both of our data centers. And so we've got to figure out the data center interconnect portion. Can the Apstra intent-based system help us with that?
Gladly. When we look at virtual configuration, you could configure remote EVPN gateway. What it really means, it's going to configure EVPN peering with remote data center and exchange all EVPN routes. So two data center could be merged into a single routing domain. In routing language, we call it over-the-top DCI. Let's create a new one. Not original here. IP address of remote gateway. ISN number. Let's say it's going to be 10 hops away. We will keep default, keep alive, and hold timers and everything else. Since EVPN gateway is a logical function, what I can do is to actually choose devices is going to be instantiation. So if I don't care about resiliency, I could just choose single leaf. However, if I want it to be resilient, I'm going to configure it on 2 leaves, for example. What's also important here, I haven't configured BGP EVPN on remote side. So when I'm going to create the gateway, you will actually see anomalies because BGP session wouldn't come up. But the point here is to show you how quick it is done, how easily it is done, and it's really number of parameters you just need to provide. As usual, unique name and remote IP address and IS number. So configured, you see all the parameters we have expressed: name, IP address, ISN number, TTL, and default keep alive and hold timers. It is also attached to leaf 1 in rec 1 and leaf 1 in rec 2. As we said before, when you configure something with AIS or Apstra intent-based system, nothing is getting configured unless you are going to commit. So it's still an uncommitted state. Now I'm going to configure gateway and committed configuration. Scott, we are done.
Wow. You got that done faster than it took me to make another cup of coffee. It's pretty impressive how fast the Apstra intent-based system can make all this stuff go. All right, so here's another scenario. Now, this never happens in the real world, right? The application team called, and there's a bug. They want to roll back that application. They're going to postpone the marketing launch. They're going to postpone the sale. The application team is rolling back their changes on their infrastructure. The network engineering team needs to unconfigure all that stuff that you just pushed out. I know in Junos we can log into each of those switches. We can do a configuration rollback. It's really easy, but we've got to go box by box to do that. Make sure we hit all the boxes that we touched before. I bet the Apstra intent-based system can do that a lot quicker. But this time I'm going to give you a little challenge. So we're going to put up a stopwatch here. In 1 minute, I want you to see if you can do it inside of 1 minute. Just roll back that change that you just made.
Happily. So as you could see, Scott's gateway is now configured and alive. We are going to time Voyager and going to roll back to the previous state before configuration happened. Rolling back. Committing the rollback. No gateway. Going back to stage view, gateway is gone, deconfigured like never existed. Unfortunately, you weren't able to finish your coffee, but hey, we are fast.
That's so cool. We love rollback in Junos. Now we can do it across the entire network in seconds, just like you saw. So, what other cool things about the intent-based system do you want to talk about? Things break. I mean, we've kind of taken away or at least hidden some of the CLI stuff from the users, from our administrators through this interface. What if something breaks? What if something goes down? Are there tools here that we can troubleshoot with, we can monitor with? Give us a little tour.
Sure. So when you use intent-based system, you should never configure things directly into CLI. It breaks the intent. It breaks the synchronization between intent, a system understands it, and your configuration. So I'm going into CLI. I'll just configure something. Let's configure. Let's actually break interface. I'm going to disable interface XC000 that connects the sleeve to the spine. And to validate, let's take a look at leaf. So you could see XC000 goes to spine 001. New configuration has been committed. Now we are going to see system complaining. So what do we see? We see anomaly in configuration. System always holds the last known configuration. If you go and configure something by hand, it will immediately figure out that there's a what we call configuration sleep. So it will give you ability to either accept new configuration or rollback. So if someone went and configured something, as administrator, you always have an option to click rollback and it will completely delete all the changes. Now let's take a look at all the anomalies. So we see problem with cabling. So we don't know that this problem has been caused by configuration because we don't know what the configuration is. It hasn't been generated by the system. So from our perspective, someone cut the cable or disconnected it. So as you could see, cabling problem, interface on leaf 1 is not connected to interface on spine 1, and this has been validated by LLDP state. BGP session, actually there are two BGP sessions, one for underlay, one for overlay, that go over the link to spine link is down. So we see this problem as well. You could see that on leaf BGP session towards spine went down. So the expected value as per intent is up. The actual observed value is down. More important and very interesting, we validate all the routes exchanged. So as you could see now, we take every route present in underlay and validate its next hop. Since BGP session is down, next hop is going to be different because now we are going to learn it through another switch. So as you could see, we show you that all the routes that were present directly from the leaf one are now either missing or partial based on the status. So some routes disappeared completely, some routes are learned but with wrong next hop. So all the validations are here and they allow you to understand what is going on. If you are going to dashboards, you will see exactly what's going on in very high level overview. So total we report 4 anomalies. There is number of BGP anomalies, and there is 1 configuration deviation. And we can also show you what has been changed. This is an expected configuration gold. If we go into here, you see, this is the problem. That's exactly what I have configured. I have disabled the interface by hand. So Scott, what do you think? Is it useful?
Yeah, Jeff, I think that could really help an operator's day to day. I mean, there's a lot of really cool tools here to just make an operator's life easier. Uh, so, what if we wanted to just roll the whole network back to where we started? Can we do that?
Absolutely. So what you see now, we are still in highly anomalous state because of interface being shut down. The number of anomalies is significant from BGP to cabling to interface state. So we decided just to go back where we started and start from the beginning. So our initial state was before we configured Scott as a service. Sorry, Scott. So we are going to go to the previous state. By single button click, I have not only reverted one device, but again, every device on the fabric is going to go into first state after we've built the fabric. We are going to commit it. As you could see all the changes that rollback is going to create. It's going to remove both security zone and virtual network called Scott from the configuration and go back to completely clean fabric without EVPN. So let's commit it. Full rollback. If we go to stage and look in virtual, you could see that there is no virtual network, there is no security zone. Only default INET 0 instance is there. If we go to the switch, we should see exactly the same thing. The BGP EVPN routing table is gone. Configuration of VM3 is gone. And configuration of routing instance Scott is gone. We are back to where we started.
Wow, that was really cool. So we're really excited about the Apstra intent-based system. You've seen us design a network, deploy an interconnect, a data center interconnect to support an application, rolled it back, showed some troubleshooting and indicators of what's going on. We really think that this tool can make the life easier for network engineers, for network operators. Give them time to make coffee, maybe. So we're thrilled about it. Hey, Jeff, thanks a lot. It was a pleasure.
Thanks, Scott. Love working with you.